Hi, I'm Dr. Jason J. Campbell, and I want to thank you for taking the time to watch my videos. I've received quite a few messages on my video series on predicate logic. I have a lot of people who watch my videos who are professors, who are physicists, who are graduate students, higher level sort of logicians, and I've gotten some pretty technical questions. This video is an attempt to answer some of those questions. The main question that I've been getting is, what can we do? What can we really do with our predicate logic beyond sort of the introductory stuff? This video response then, I'm tempted to make the response a very technical response, but I don't want to lose the audience of people who are following sort of progressively along. So I'm going to go against my sort of inclination to just respond very technically. And what I want to do instead is I want to create an atmosphere that will both address the answers that those who are very, very proficient in logic will understand, but those who are just getting a taste of sort of how this works will be intrigued to learn a little bit more. So it's not going to be an easy lecture for me. Hopefully it's an easy learning time for you. The lecture will be difficult to give. But if I'm successful, you're going to be able to see how very isolated branches of logic, very esoteric branches of logic, can all factor into strengthen and make sense of our formal proofs of validity in predicate logic. What in the world does that mean? Okay, this lecture, I had the idea, right, to sort of fuse three branches, three facets of logic that are almost never spoken of as an integrated, never spoken of in an integrated discussion or an integrated lecture. They're always spoken about separately, and I want to show you guys, both the professional math geeks and those who want to get familiar with that discussion, how we can make our logic more efficient, right, by borrowing from different branches of logic, right? All too often we say, oh, well, I'm doing symbolic, or I'm doing modal, or I'm doing sentential, or I'm doing some other branch in, epistemic, and, they all have their own governing rules, and we talk past each other as logicians and mathematicians. And I'm not a professional logician or mathematician. I mean, I'm just a regular dude that does this really as a hobby. I'm just, this is what I do for fun. So in that sense, what I'm presenting isn't anything new. This is rich within the tradition. It's within the framework. I think the only thing that I'm going to do today in this lecture is put a different spin on it, right? I'm going to show you, both the very, very advanced viewer and the introductory, the beginner viewer, that what we need to do is to make sure that we recognize that there is a common foundation within our logic, and this foundation can be used to strengthen not just our predicate logic and our formal proofs of validity within predicate logic. It can strengthen our symbolic logic. It can, and I'll show you how it can strengthen our symbolic. I'll show you how it can strengthen our predicate, and so on and so on. The point is that mathematicians, philosophers, logicians, no one's really saying it, but we are, in a sense, attempting to see if we can recreate the cognitive, epistemological abilities of the human mind within artificial life forms, AI, right? The whole point of AI is that it can mimic what we do. You can take, maybe not this, I mean, what I might present today will be rather advanced, but even this, on this very, and I'm going to try and present it in a very, very simple, very, very basic level. These ideas are sort of the foundational claims to much, 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 much more advanced, extremely advanced sort of mathematical and logistical concepts like neural networking and I mean really advanced, anatomical networking and pharmacological networking. I mean, you can get very, very technical in the attempt to sort of reproduce within artificial intelligence the workings of the human mind. Once you recognize that the workings of the human mind function in a logical sense, yeah, it's on off, it's yes no, it's conjunctions, it's biconditionals, it's equivalencies. That's how we think. We are logical beings. the more precise our logic gets, the closer we get to possibly, recreating that in artificial intelligence. And this is the big to-do with, sort of Asimov, the androids and cyborgs and all that other stuff. Plus, we're geeks, so who wouldn't want to have a cyborg? I think it'd be pretty cool. So as out there as all that sounds, as sci-fi as all that sounds, it really does have its basis sort of in this discussion that I'm about to give. Again, as I said, this is nothing necessarily new. I think the only thing that I'm going to be contributing, if anything, in this discussion is sort of a recognition to the community that we shouldn't be talking past each other, that we are all talking the same language, and the stronger our logical and mathematical grounding is amongst those who sort of dabble in this, the better and the more efficient we can become. And what I'm definitely going to show you today, or else this lecture is flopped, is a more efficient method. And it's not my method, I'll show you in a second, a more efficient method for, within predicate logic for deducing validity within an argument, right? So it's definitely not your intro discussion, but I'm going to try and make it as intro as possible. With that, let's begin. This is going to be Polish notation, N-O-T-A. And I should put the Polish notation system. Nand nor operators. Informal proofs of okay. So the Polish notation system, sorry for the title, and I'll explain this in a second. The Polish notation system, Nand nor operators, and formal proofs of validity within predicate logic. The question is, what is Dr. Campbell trying to do? He's lost his damn mind. Those things don't have anything to do with each other, right? You got, and I haven't explained what, some of you know what Nand nor operators are. I think a lot fewer of you know the Polish notation system. Hopefully by the end of this discussion, if I do my job right, you will understand how to use the Polish notation system. And in predicate logic, it's like, okay, predicate logic is here, Nand nor operators are here, Polish notation system is here, they don't have anything to do with each other. That's categorically false, right? The whole point of strengthening our logic, the whole point of seeing how far you can take something like predicate logic, which has just traditionally been used to symbolize stuff like, Socrates is a man or something like that, very sort of mundane things. The tradition's been doing that for years, and that's the old hat. It's like we gotta step it up, right? And I'm not gonna just do a lecture on predicate logic that everyone's done, right? There are some amazing lectures on predicate logic out there. That's not knocking people who've done them. They're great lectures, and that's why I said in the last series I'm not gonna just do the same old thing because it's already been done and it's already been done well. My whole point in being on YouTube is to try and put my interpretation on a lot of crap, particularly philosophical crap, out there, and have you guys discuss it, and just contribute to a global understanding, right? I'm not doing this for anything other reason. And the biggest problem that I have, especially when I speak with and I have a lot of people, I get a ton of email, but I have a lot of people that I talk with, and it seems as though, especially when you're talking to somebody who's very, very mathematically inclined. I mean, I have professors of physics that I talk with. We at times have a tendency to say, oh, I'm talking about modal logic, not epistemic modal. I'm talking about symbolic and not notations in the Polish system. And what I want to say is that all of these are the same, right? It's all the same, right? We even get confusion over the operators, right? So in one of the previous sets, I typed up all the different operators that I can think of, showed you how the operators were the same so that there's no confusion, wrote out all the proofs of inference, and then wrote out the words for what the symbols mean so that for the very, very introductory learner, you can see and understand that this symbol means that, and here's how this, here's the structure of what is said. This is absolutely important, and my whole point is not to keep the knowledge for myself. I mean, what type of educator would I be? It's to disseminate it, right, and to get it out to as many people And not only do you get it out to as many people as possible, but to make sure that you understand this. Why? Because things like this lecture, if it goes well, could and should change how we go about the pedagogy of logic within academia. The way that I teach logic to the world, to you guys, is not going to be like the way that, and I'm not knocking my logic teachers. I had some amazing logic teachers, right? But, I think we just been doing the same system of education in symbolic and modal and higher forms of logic. And, we need to think outside of the box because, in a sense, they're all related. It's all related. So enough of this spiel. I apologize for preaching, but I just wanted to, address, because I've gotten a lot of questions, a lot of feedback. And, this is my 2 cents. Okay, so the first thing, what I want to do is we're going to talk about the truth table, the truth function of NAND NOR operators. You do need to have, for an understanding of this discussion, a basic understanding of NAND NOR operators. I will not be discussing NAND NOR operators like the electrical engineer's circuitry and all that. That has no relevance for me. It's strictly sort of the logic. That's the only thing that I'm going to be analyzing in this discussion. Also, for the Polish notation system, you don't have to have any knowledge of that. I'm going to hopefully educate you on how to use that system. But you do need to have a pretty good understanding of predicate logic. And hopefully you have, if this is your first time watching it, then watch the first, I think, videos 4 through 8 of predicate logic, and that'll give you an introduction to some of the ideas in predicate logic. So don't worry if you don't have a good background in some of these things. Hopefully by the end of the discussion you'll be somewhat proficient. Okay,